of mine. We do music together, so it's always nice to have someone on who I'm very close with. So let me explain a little bit about this particular session. As you know, the goal of this channel, and it's very new at this point, is to kind of cover a lot of different areas in the information security space. And I like the talks to be technical. Some of them will be very technical, some of them a little bit higher level, but I always want you to be able to take away something from these streams and not have it just be, playtime where we just chat about random things. Although that is fun sometimes. Maybe we'll do like a, I don't know, InfoSec music session or something at some point. But the reason I asked Steve on is, one, his company Halborn that he started less than a few years ago is incredible and has done incredibly well, going from just Steve and his partner, the CEO, all the way up to, how many employees do you have now?
Close to 120 right now.
So yeah, close to 120 employees, and is absolutely probably the leading consulting company, boutique consulting company in the area of blockchain security, smart contract security, crypto, and then of course other pen testing and such as well. And I met Steve when he was attending some SANS Institute events, and we met, I think it was at Hackfest or something like that a couple of years back. And then he came and took 760, which is my advanced exploit development course, and did incredibly well, won the coin, and definitely was a great student in that class. And has been like a Net Wars Tournament of Champion winners multiple times, and so on and so forth. And so he was telling me about his interest and expertise in this space. And we talked about cryptocurrencies, of course, and he helped me with my investments there and my fear and greed index, and, getting freaked out when Bitcoin goes up to 67,000, drops down, back up again. But as I started to learn more about crypto and the whole space of smart contracts and blockchain, I realized how much I didn't know and still don't know. And he wrote a 3-day course for SANS called Blockchain and Smart Contract Security, which is now a 5-day course. It just had its alpha run. We're going to have the beta run coming up in December at SANS CDI, and then it will go back on demand and such. And again, I realized how much I don't know. And even though I know a lot more than I used to, I still don't know very much. Like, it's just absolutely amazing when you hear someone like Steve talk. And again, that's why I had him on. So I really just going to let him talk for the most part today. And I'll chime in back and forth, and we'll have some banter kind of going over some hacks. And I think he wants to show us a couple things in particular. So I'll welcome Steve.
Yeah, definitely. Yeah. Thanks for having me. And also thanks for everything else, for really helping to get the course out there for SANS 554. It's having that blockchain smart contract security course and expanding it into the 5 days really shows that the industry is growing, and there's so many new things to teach with it. I mean, I could probably make it a 10-day course if you let me for that, and if I didn't die from writing all the time. But it's it's really cool because there's a lot of things in blockchain smart contract security that is similar to traditional security, things that you'll see in networking, that you'll even like social engineering and application security, but it's putting it completely, putting a different twist to it. And then a whole bunch of new things that have never been seen before, like different, different top 10s for vulnerability types and different categories, different languages too. So like Solidity is the language that's used for almost all of the EVM or Ethereum smart contracts. And then we're seeing a lot of Rust programming languages, very, kind of similar to C, and we see a lot of Golang. So if you have a particular discipline in cybersecurity, whether it's from physical security to social engineering to AppSec to network, there's a place in blockchain for it as well, and Blue Team too. So that's one of the things that we expanded it into. So it's a great translation to move into this space if you want something fresh and new and have a different approach, but still kind of like keep yourself tied to the familiar aspects of really technical security and hacking and offensive security. So that's really interesting. And then from all of that, there's a whole another layer around it, which is, I like to call like financial pen testing. So you have the code hacking and buffer overflows and memory exploitations, but the business logic, like all these smart contracts that you see and interact with, you can hack the business logic for it, like with financial services. And one example for that is doing like a flash loan type of attack. And you'll hear that term a lot. A flash loan is not particularly a vulnerability, but it's a way to borrow millions of tokens or dollars or whatever amount you want without any collateral, just like getting a loan from a bank. You get a loan for one block, around like 15 seconds. That's why they call it flash loan. And you could do something with that. Sometimes you can use that to, change the price of, 2 tokens. And if you manipulate the price and make it, pump it really high and then, buy it somewhere else while it's still cheap and then return back your investment, you just made a killing off of that. And, you had to like post no collateral. And that's like a hack, if you find the opportunity in the environment to do something like that. So that's why it's a whole new discipline of like financial penetration testing, which is really interesting.
Real quick, do you think, like, just comparing it analogy wise to like cryptography, where a lot of the mistakes with crypto is the fact that the developer is not well versed or experienced in cryptography, and they try to implement some part of the crypto system, and due to that lack of expertise in crypto, they make mistakes? Do you think some of these vulnerabilities are the same style, where the developer is not maybe that proficient in the space, and so they inadvertently introduce vulns, or is it something different?
Oh yeah, no, there's both. I would say the 2 sides of it is the code-based vulnerabilities on the smart contracts, and that is definitely, as you say, something that a developer will overlook or not think about, or maybe cut some corners on the code, or implement some type of logical holes inside of it, or leave some vulnerabilities that haven't been found before, but then they get exploited later, 0 days inside of the language. So that's certainly the case. For the other side of it, the financial pen testing of it, it's very, very hard to determine. You almost can't pen test for it. It's more of like a risk assessment, because it depends on the composability or the environment parameters. So, it'll only be vulnerable if, there's this much, value within like a liquidity pool, for example, or it's only going to be vulnerable if the number of tokens available to use as votes for like a governance contract or exist. So it depends on the environment variables, and that it's extremely dynamic. It changes like second by second, and the vulnerability may be there just for one block or for a limited amount of time, and then it's gone. And also you have to balance. There's a cost analysis along with it too. You may be able to exploit it, but it may not be profitable because the gas price might be too high.
Yeah. So
it's really, really interesting. But yeah, a lot of the vulnerabilities that you see in the traditional like memory exploitation certainly exist in here. I have a demo actually that I picked a particular one for you to show because of taking 760 and 660. With all of the memory exploitation and ROP chaining and doing like jumping registers, that happens as well in smart contracts. It's called EVM bytecode instead of like x86. Let me show you really quick a smart contract that you can see how it compiles and might illustrate a bit about the way all of this works. So the first thing I'm going to show here is, let me switch over to my jump.sol. So you see here, my Visual Studio Code.
Yep.
Cool. Awesome. So there's a vulnerability on here, and it's using low-level functionality allows arbitrary jump with a function type variable. So low-level functionality, what that actually means is right here, there's a certain section. When you see assembly, assembly is taking the code, the Solidity code, and putting it into like a hex version for it to run inside of the EVM. And EVM is Ethereum virtual machine. So if you can kind of inject code, it's like a code injection. You can take the hex and have it start to do different operations to jump around, like jump and pop and push and is zero, all the things that you normally see on the stack. And we can get control of this to extract value. And I'll show you how that's done in a second. But this is a particular vulnerability that a developer can overlook. And the why it occurs is because the developer, if they use those assembly level instructions, one of them is mstore, which is like memory storage, putting something into storage, then an attacker could use that to like, a pointer, like the EIP, to point to a certain place on the stack. And that's really what's happening here. And you could point it to connect to internal functions. So if you see this function here where it says internal withdraw, internal means that you're not able to execute this as a user. Only internal functions can really call this. But if you jump into the contract, if you can bypass that, you can execute it. So that's really something very similar to what you would see in like finding an exploit in memory and jumping, doing a NOP and like a NOP sled down into it. So let me show you on the chain. I actually took this contract and deployed it onto a local blockchain. So I'm going to switch really quickly over to the actual chain here. And
how
then
common do you see that in the code you've audited?
Oh, how often? Yeah, we see it pretty often. It's I mean, there's vulnerabilities that come up just all the time from things, but we're here to protect it. So before people, because really money can be lost immediately if with this. So
yeah, I'm very curious as to how you would actually get control of the instruction pointer and such on this. Is pretty neat.
Yeah, definitely. I'll show you. Yeah, we'll go through real quick, and I'll show you like the op codes are different than you're normally used to. So this is the contract that I just showed you that I deployed, and this is the address. So I'll put that into the GUI in a second. But you see, it has one Ethereum inside of it right now, and I just created it about an hour ago for you guys, and we'll come back on here and see the transactions and if the coin balance is reduced, because right now we could see that it has the one Ethereum. Okay, so what I'm doing, I'm gonna go back really quick and to the really like what the stack looks like. So
I love that you're using your own real money for this demo.
No, this is you can actually make test Ethereum.
Oh, okay.
No, this is not on mainnet. It's toy money, I guess you could say, right? Funny money. All right, so here is, we'll go to the Brownie GUI. All right. So here's that same contract again. And this is, the code without all the comments on there. And you can see each one of these, functions here have, this is the entire EVM assembly stack. So there's pushes, jumps, call datas, and loads, and everything. So if you could, just like finding a way to jump, or using different gadgets to jump around, you could do the same thing here. So, break it is the public payable function. So this function being public means you can call this one as a user or from the outside. So we're going to call this one, and you can see here that there's this assembly tag that will take it. Assembly will turn it into that assembly code. And if we can inject and find a place to land on a jump and hop into where we can withdraw, then we'll be able to kind of like bypass that control and get into the part where you can have it send funds to yourself from here, the withdrawal. So the idea is to call break it, add in a certain value because it does take a value, it's payable. The value actually turns into assembly, and then that assembly will move and kind of jump you into this function for a withdrawal, which is coming from the internal, and then it'll send give the sender and transfer out the balance to that. So it's using that by hopping out from here. We can see like this assembly is about at 134, and with pop, then it goes to the jump destination, and then the jump destination will eventually call a value to load out and store, and then execute a swap balance right here. So that's the idea. It's like using that, injecting the assembly to hop over there. Okay. So I'm gonna go back now and run, show you like the exploit, and we'll go back to the block explorer here.
Cool.
Am I making you this is much more very familiar to 660 stuff?
Yeah, definitely got my interest up.
Yeah. All right. So back to the code here. All right. So what this is here, I'm using something called Brownie. Brownie is it's a framework that uses Python to like interact with contracts. And I took my jump contract, and there's that B0291. That was the one I showed on the Block Explorer. So it's deployed, and we can even see the balance for that. So jump and the balance current. Let's to make sure that there's money in it. So that's money. That's actually equals 1 Ethereum. So Ethereum can be broken down into components called GUI, and this is like 1 trillion GUI is like 1 Ethereum. So that's the balance right now, and yeah, we want to break it. So if we look at the jump ABI, so we can see the jump ABI here has that input break it. So break it is the function that we can call. The other ones are internal, so that's why we don't see them here. So we're going to call break it, and we're going to send a certain magical number that will think it's sending GUI, but it's going to then turn into assembly because of this assembly here and jump into the withdrawal. Well, so what I'll first do is send in a value that does not jump correctly.
So can you explain that a little bit more? Why would it interpret that as such, and
why was it so? So just like an assembler, in Windows or Unix, EVM has its own bytecode and assembly language, and when you kind of get control, if this only happens when you have this assembly command. So the vulnerability appear if you see here. The problem arises when a user has the ability to arbitrarily change the function type variable and execute RAM code instructions. So because we have assembly, we're allowed to, the user can now use assembly instructions to have it create different EVM opcodes. So you're injecting like opcodes in there by introducing this assembly command, which is on line 36 here. So if this didn't exist, then when you send it a value, then it'll just think it's Ethereum. But because we're sending it a value and it's turning the value into assembly, now it thinks it's in operation code.
What would be a use case where you would need that assembly instruction? Because obviously it seems dangerous right now.
Yeah, if you wanted to change like some storage values, like because when you deploy something on the blockchain, you can't really undo it. You can't roll it back. You can't take it off the blockchain. It's immutable. So if you wanted to change some type of like memory structure or storage structure, or maybe even change some string values that are like permanently written there, you could maybe update it this way. So it's recommended not to use it too much. It's actually, there's a risk category in like the SWC, which is the different like vulnerabilities, tags, and identifications for it. They recommend not to do this unless you like really know what you're doing.
Yeah.
Yeah.
Hassan had a question. I don't know if you see it over there on the comments. Can you see the comments?
No, I don't see it right now.
Okay. Yes.
Read me though, if you want.
What's that? Oh yeah, read it. He said, is it going to jump to the function offset or a full memory address? If it's a memory address, does it require an info link, or there's a way to get it from the public chain?
So it's going to jump within the contract itself. It's not going to like jump into like somebody else's contract, like on the blockchain. It's only within, there's memory within Ethereum. There's storage within Ethereum, and then there's call data. And it's kind of like, think of it as permanent memory and temporary memory and volatile memory. So this isn't going to go and update any of the memory that's like in another contract located elsewhere. It's kind of done within the execution itself, the call data.
Great.
So here's one you could see. This is like not that I sent. Let me like show you exactly what this command is doing. So jump is the contract, and I'm doing jump 0 because I loaded it inside of this array. So jump 0 is the contract target. Break it is the contract function that I'm calling, and I'm calling it from my account. So this is like my wallet. If I type in accounts, you'll see here. That's my wallet account. So I'm calling it from there. This is just a gas limit, parameters you give it to it. And then here's the value. So value 7, I could, call another value if I'd like to. Maybe I can call, 10. This isn't working. Really, it's doing it. It's converting it into, the assembly, but it's just hitting somewhere on the stack that is not, it's not executing anything.
So
and
it's
that's
just
how
jumping to an offset somewhere.
Yeah, exactly. Some random like opcode is like, this doesn't make any sense, and it's like not hitting the NOP sled pretty much. That's a similarity for it. But when I call this one 71, you can see here that it didn't revert. And that is a number that actually, when you convert it to, let me see if I do 2 hex 71 0x47. So it's adding 47 hex into it, which actually lands right on the jump destination that will jump it into the internal. So now if I look at the balance of that contract here, back to that, jump balance, and jump, I have to do the jump 0 array. Now the balance is 0. So I actually took it and transferred it out into my own account. So I'll go back to the block explorer that we saw before and see if it actually took that. So let me stop my screen.
Have there been any public examples of a bug being exploited like this?
Yes. Poly network hack, one of the biggest ones ever. What happened was they jumped not to steal funds. They jumped in order to hit a internal function that updated their privileges.
That was because of that assembly function?
Yep. They found a conflict. They found like a hash collision that allowed them to jump to an internal function.
Nice.
Yeah. So share my screen back to the block explorer. Okay. So now if I go and look at this, let me go back and refresh. Here, I'll go back to blocks. And this is my own private blockchain, by the way. So it's still mining it.
So your Zion VM that Halborn released, is that something that has all the tools needed to be able to practice stuff like this?
Most of them, yeah, for sure. Yeah, this is this particular one that I have up right now is I'm using a CTF platform. And this is the CTF platform is like a way to deploy into my own private blockchain. We use this internal at Halborn. So here, that's a contract I deployed here. Now, if I go in and check that contract, we could see that now the balance is 0 balance. And yeah, here's 3 minutes ago. So these are the first. Remember the invalid destinations? I put in random numbers, so you can see these are like invalid jump destinations. But that one, once I hit 71, it succeeded. And now the coin balance, block 1 is now 1 Ether. So it's able to jump out and execute that withdrawal.
Yeah, awesome. That's neat. I mean, and the truth be told, like the impact of this, even if the vulns are far and few between, when there is one, it's a pretty serious amount of money.
Oh yes, yeah. This is just 1 Ether of play Ether that I deployed on a contract. But if that was, if that was a real contract that you sent out and people started investing money into it, like real money, and I could be a hacker. Just I found that vulnerability because all of this is open source. I could be like, oh man, what a dumb developer. They left like the assembly there. I could jump out for it, just like waiting and watching funds get put into it. Like, great, it's up to $10 million now. Let me run my 1 line of code or my 1 command and then just take it all.
Yeah, it's terrifying. I remember reading about someone on, I can't remember where it was, but paying some influencer on TikTok to like push this particular cryptocurrency that was, basically saying, hey guys, I want you all to know that this is on pre-sale right now. Most of the public doesn't know about it. So the faster you go and buy a bunch of it, the better. And the influencer didn't know that there was some scam going on, and they did one of those rug pulls, of course, and took all the money.
See, there's the social engineering aspect of all of this too. Yeah, some of the craziest like scams and like Ponzi schemes like that I've seen. It's really sad because everything is public on the internet. But I've seen before these really hyped up tokens that there'll be copycat tokens that come out almost exactly the same time. And a lot of these communities are on Discord or Telegram or some other type of like chat room. They'll go to the APIs and like pull the whole like list of community members that are in there and then send them a message saying like, hey, you got selected for like the pre-sale, join this channel. And then they're all like, oh, excited, like, oh, wow, I'm so special. And then they launch the token, but it's the same exact name, the same exact like token. They just copy all the marketing, except they put in like a backdoor rug pull function on that one. So people rush in, throw their money in there, and then they just like execute it and take all the funds out. So they've just used like social engineering and people's lack of awareness and kind of like excitement
it's sad too, because like crypto was gaining popularity and there is real world context and use and everything else associated with it, but all those scam coins takes away the trust that people have and like hurts the whole thing as a whole. It's like makes sense, at least to me, for us to be moving toward in this direction, but it definitely didn't help things. And has that gotten better? Like are there controls in place, or are people just getting more savvy and aware of it?
I think it's a bit of both. The controls are becoming better over time. People are becoming more aware. I mean, that once you get burned a few times, you kind of like learn your lesson. But Halborn's been making tools to protect smart contract execution by adding notarization for it, some prevention. There's a couple tools we've seen that kind of sit as a layer between like the wallet and the contract, kind of like a middle layer to find known bad, almost like signature detection on contracts too. Auditors are getting better. And I think now why Halborn has such great growth and success is, developers are realizing that, security testing is extremely important because you really get one chance. And so a lot of the development phase of creating the smart contract code, we are checking it and they audit it, and they it's almost mandatory now for that. So I think it is getting better for sure, and it's also becoming a lot more awareness is around all of the different hacks and vulnerabilities, because it just happened like so often to people.
Yeah, Hassam says, is it like Oracle?
Is it like Oracle? Yes, it is like Oracle. Yep. Yeah. Oracle is this is similar to the smart contract. The jump one is like Oracle one. We actually have this inside of our homegrown CTF server here, which part of like at Halborn, like it's all like our boot camp. We have a lot of like capture the flag environments that we create internal to for our engineers to go and test on. So we can deploy these into like a private test network, find exploits that we've seen from our clients, put them on there, and kind of like build up our training arsenal there so that we can become better, because this is all brand new. A lot of the people that start at Halborn, they're coming as pen testers from web applications or other traditional security, and this is all new to them. And we're all about education. That's why we partner with SANS, because I think we're more researchers and learners and students than we are like career pen testers, which is cool in its own way. I'm a lifetime student. That's why I took 760 with you, got the challenge coin. Like, okay, what do I do now? There's when 860. So I was like, what? Let's just make our own class. How about that?
Yeah, for sure. What's another example of a good like kind of cutting edge latest thing you've seen out there that maybe people haven't heard of?
Man, well, I think a lot of the cutting edge stuff is in these layer one blockchains. So everything we look at just now is like smart contracts on Ethereum. It's very well known, like lots of value, but the cutting edge is people that are developing like these cross-chain bridges and trying to connect Ethereum to like Rust or Golang or Substrate or some other type of language protocol. And like, how do you link those two together? I mean, I guess it would be similar to, you have a Windows application built in .NET, and you have a Mac OS application built in Java, and he wants to transfer communication between the two of them. How do you do that securely? So
Yeah.
that's a lot of what's going on right now is finding these weaknesses in the way that they're trying to connect these chains together to swap. And unfortunately, there's two ways of doing it. One is doing it decentralized, which is allowing it actually having them talk to each other on like a parachain. And then the other way is using centralized solutions. Like I have a database on one side and a database on the other side, and it's running cron jobs to like match them up. And that's, that can become very, very vulnerable.
Yeah, it's neat. Anytime a new attack surface gets introduced, that's fun for everybody,
Oh yeah, more complexity for sure. And then whenever you this is like one of the fundamental things about blockchain security. Whenever you implement like centralization into it, then you're opening a whole other like area of risk, because now it's private key custody and just really people security too. Like centralization is rug pulls is centralization, like one owner being able to extract everything out from it.
Yeah, I think Hassam asked one more question. Can this Oracle thing block that jump issue?
Oracle, no. So actually, the way to block this would be first, don't use the assembly level to have user input be provided to it. So if you have user input into an assembly function can control like the opcodes, that's just a huge risk. So that's like code. The other thing to do would be a solution like what Halborn has. We call it Seraph. So Seraph is a new tool that is doing prevention by sitting on a function execution layer. And every time there's a privileged function that gets executed outside of normal operating conditions, then it has to be notarized. So Seraph is something that we developed that's doing blockchain notarization. And it's think of it as a way to do transactional level audits. So instead of like auditing the whole code before it gets put on the blockchain, this is doing every transaction. If it's a privileged transaction, it gets audited and then it gets executed on chain. So that's the other way to prevent this.
Nice. There's another question I was going to ask you. It's a problem, me when I was in your class. I was like, question.
Well, you haven't even taken the new 5-day version yet.
Yeah, I'm hoping to sit the beta when we do a CDI conference. Yeah. So, is there anything else you wanted to show us or talk about, or?
Man, I could talk about this all day long. How much time you got?
Yeah, I know.
No, I think I may have a plug for like the class, since it is coming in and you're going to sit beta. So the 5 days, because it's such a broad topic, within blockchain security, and it's new. So the first day is around like all of the basics, like what Solidity is, how to code it, how different proof of work, proof of stake, how that all works. And then day 2 is the Solidity hacking, which is kind of like what we looked at just now. And then day 3 is into like another language. So it's doing Rust based security, which is Rust is like Solana and Polkadot, and a lot of these other newer chains are using that because of how fast it is.
The question there, Rust is, I've looked at it a bit. I'm definitely not good at it at all yet, but like I know a lot of people. Microsoft obviously stands behind it, and I think Mark Russinovich even said all new big projects that are like low level style should be written in Rust. We need to let go of C++ and C because it's much more safe, and it's an unsafe function, of course. But I guess if Rust is being used in those situations, like what's the vulnerabilities that you have seen? So it's like what kind of vulnerabilities appear?
Yeah, it's still memory. It's memory safe. It uses the concept of like borrowers for the memory, and just like C, it's a difficult and very frustrating language to code in. Because of the compilation. If there's it's you don't like set your types there, it's not going to compile and it'll warn you. So, but it also is extremely fast, and the vulnerabilities that come from this now are things like vulnerable, like what they call crates, like imports of like vulnerable packages. It could also be things like like buffer incidents that'll like overwrite types, so if you have like bad type checking, and then of logical. So like, and Solana uses it. Everything is an account. Like every time you compile a transaction will be a binary that you deploy onto Solana. If you wanted to put in like a smart contract, it's actually a program that gets compiled and put on the blockchain. Every transfer is its own binary. So it does that through privileged execution. And if you code that incorrectly, where somebody could become like a system account or a system binary with high privileges, then you could do flaws that way. So that's a lot of the really, really bad ones on Rust for Solana are around doing account privileged takeovers of like liquidity pools or contracts.
Yeah.
So, yeah, it's more of that than something like you would see on the demo I gave earlier.
So there's Rust and Solidity covered in the course. Are there other languages as well that are covered in the course or popular?
That's the two ones that are covered the most. But after that, the rest of the course, day 4, is not about the languages. It's about the financial side of it. So there's the DeFi exploits. That's the one where it's not about like the Solidity vulnerabilities or the Rust vulnerabilities. It's about flash loan attacks and Oracle attacks and governance. It's really, they call them protocols. So DeFi protocols are financial services, and then the vulnerabilities that happen with that. I mean, everybody knows about Terra blockchain, and Terra blockchain is the one that like completely collapsed because their stablecoin became unstable. That wasn't really a security incident. That was just, a flaw in their algorithm that allowed that took it off the peg. It uses this balance of Luna and a dollar to create arbitrage to maintain its stability, and somebody with enough capital was able to like push it off of its peg and cause a death spiral. So that's like a financial vulnerability. And then the last day is around defense too. So day 5 is great. I'm very scared now. You made me not want to do cryptocurrency at all with all its flaws and issues. But day 5 is for like the blue teamers, and it goes into everything like the tools that are available for monitoring, like Forta and Tenderly and Seraph, and how to use them, and also goes into the compliance. So the administrative type of preventions with some of the laws and policies coming out, and then things around like the social engineering aspect and privacy attacks. So if you're law enforcement going on the dark net, how do you see or track down like stolen funds, and how does Tornado Cash work? So it's going into like a lot of the defense and forensic side of it for the last day.
Yeah, I remember I've said this before when we had the blockchain summit a couple months back, that when I took your class, the first run of it, there was like multiple law enforcement agencies in the class. Like pretty much the whole class are like, how do we break Monero? How do we track down people? How do we de-anonymize? And like with the fork of Monero recently, I'm imagining it's a lot harder now to privacy.
Yeah, really hard. I did an interview with Bleeping Computer, the same day that they had the fork, and to make it stronger. And there's like, is this going to make Monero weaker? And there's like, nope. So if anybody's frustrated with trying to crack Monero before, they can do more now, because they made all of the rings, the ring signatures, they doubled that, and they just made the hash algorithm tougher and more privacy. I mean, Monero it's such a privacy coin. It doesn't have its block explorer either, so you can't trace funds down like you can on Bitcoin or any other ones.
Yes, but I was reading an article and I didn't quite understand. I'm not sure if you know about this one, but it's like a warning to Monero users. If you go and try to execute a transaction and it looks like it goes through, and then it comes back and said the transaction failed at some point, the warning was like, don't just reuse the same node that you're currently connected to and like change everything before you do the transaction again, because there's apparently some privacy issue with that. Do you know about that?
That's just that's shady in itself. It sounds like a man in the middle type of thing, where a malicious node or malicious miner that you connected to is trying to do a forced reuse attack on there. There's different type of manipulation attacks that occur like on Bitcoin too, like dusting attacks, where they'll place a little bit of funds inside of like an unspent transaction to see who picks it up when you send more funds for it. So dusting attacks happen and this could be either like a malicious Monero miner that you've connected to, or they could be trying to do some type of like dusting attack by having you like use your spending key reuse too. So I would say follow that advice, because I've never experienced that in any Monero transactions either.
Yeah, Hassam asks, I know we're going to wrap it up here in a moment, but Hassam asks, it doesn't have Explorer due to the network calls, RPCs, or no one wrote one. I mean, from my understanding, it's that the addresses aren't actually used. If there's like kind of one-time addresses or something used, and you explain it better.
Yeah, definitely. It's one-time use, but also for Bitcoin, you want to use it one time. Monero, they have spend key, view key, private key, and transaction key. So you have to have all of those keys in order to like see anything or reuse it, or even like view your old transactions that you've done. So yeah, it makes it more complicated, but of course it's also makes it more secure.
Yeah. Cool. Well, I think we need to wrap it up. I know you've got work to do, real work, besides sitting here with me, although I know we could chat all day on this stuff. We did have the blockchain summit though a couple months ago, and there were a lot of amazing talks recorded. And I know Randall, our marketing guys here in the background, and I know that if they haven't been posted yet, that we will post some of those talks. So it's a really, really great talks from just expertise that you don't often get access to, which is amazing. But thank you very much for coming onto the stream here, and I definitely want to have you again. Maybe next time we can walk through some more specific attacks. But yeah, that's really neat, that the concept of like getting control of the code execution flow, and it didn't look like there was a ton of